Hello and welcome back for spring 2021. Some of you have already seen my video for the lab, so sorry there's a little bit of repetition here, but what we're going to do today, being the first Thursday of the semester, and this class, if it were running in the classroom, it would be running on Thursdays. So my plan is every Thursday to come up with a new video to have it posted, either Wednesday night, Thursday morning, that has the content for that day. And so it's Wednesday night right now. I'm recording this, and hopefully you're watching it on Thursday, and a week from now we'll do another one. So let's start with the really basic stuff of looking through the syllabus, which I am happy to share with you. Let me just turn off my camera here and grab that. Here is Blackboard, and of course the courses you see are going to be different than the courses I see, but I'm just going to click on one copy of the lecture here and show you what I have in here, if you haven't looked at it already. So there's my info, contact info, no big deal there. My schedule, and you'll see that on my schedule here, and unfortunately, this is changed just actually last night, so I had to make some changes to it. But normally, like I said, Thursdays is when you'll see things. But if you need to see me between the labs on Monday and Tuesday, I'll have office hours. I have a Thursday afternoon lab, an air conditioning lab. I'll show up before it, and then between that and my night computer assisted mechanisms lab, I'll be here in the office. So that's my schedule, and of course that's always available on Blackboard under my instructor. And then of course the syllabus, there's nothing right now under course info, there's nothing under lessons, but lessons is where I'll be adding content. So the syllabus is there now, so let me click on that and bring it up. And you can access this whenever you want, so print it if you want, don't print it if you don't want to. But you'll see, obviously there's the computer assisted mechanisms. Here's my office hours, which are also on that schedule we just looked at, my phone number, email, that's on the instructor info we just looked at. So you have it more than one place. But what is this course, right? It's computer assisted mechanisms. What does that mean? And really what it is, it's a class that talks about all the electronic controls that cars have. And it started as a, let me turn the camera back on here a minute. So it started as a electronic engine controls sort of class. The very first things that were computerized were engine controls, and that's going back into the 80s, late 80s really, or early 80s really, and then kind of exploded in the 90s, and throughout the 90s and the 2000s and the 2010s and up till present day, more and more systems have been computer controlled. There was no thought of power steering being an electronic system back in 1989, but engines were. So we've had to completely just keep adding things onto this class year after year as more and more systems become computer controlled. Now we have things like lane departure warnings and front and rear facing cameras, just adaptive cruise control, all kinds of computer controlled things that just didn't exist maybe 10 years ago. So a lot of the examples I use though will probably still be from electronic engine controls, but here's the thing. In fact, let me just go full screen here for a second. I can't possibly explain to you how every sensor on every system, on every car, by every manufacturer works. It would take years to do that. The good news is, what car manufacturers have not really invented a whole lot of electronics. They've invented some, but a lot of the electronics that you see in cars are standard components that have been used in other things. Let me give you just one example, all right? So we could talk about an accelerator pedal position sensor, something that's a relatively recent development in cars, but in most vehicles, that's what's known as a potentiometer. So a potentiometer is a kind of standard piece of electronic hardware that's been around since probably the 1940s. Old volume controls and things like that were potentiometers. POTS, sometimes people call them. And on cars, you'll find them all over the place, generally as position sensors. So inside your electronic throttle body, there's probably a throttle position sensor, accelerator pedal position sensor, and just the position of, who knows, a blend door in an AC system probably has a potentiometer to tell the HVAC control unit or the body control unit where that door is in its travel. Is it closed? Is it open? Is it half open? And so all these position sensors all over the car are the same piece of hardware. They didn't reinvent the wheel for every single thing. So the good news here is, once we talk about a potentiometer, what it is, how it works, how you test it, then anywhere on the car you find it, you'll know what you're looking at. And you won't have to relearn everything just because it's called something else. So what I'm telling you is, inside an air conditioning system, an automatic climate control system, when the door moves from floor to defrost, there's a potentiometer feeding information back to the computer about where that door is. When you step on your accelerator pedal, there's a sensor feeding information back to the engine control computer about where that accelerator pedal is, and those two sensors work exactly the same. You don't have to learn both of them. All you have to learn is, what's a potentiometer, what's it look like on a wiring diagram, what's it supposed to do, how do I test it? So that's what we're going to concentrate on in this class. So if we go back to the syllabus, the actual description of the course, right, is the operation and diagnosis of computers controlling automobile operations. Includes, well, I got to take that word out. It's no longer called Daimler Chrysler. Ford, General Motors, other domestic, as well as various import vehicle systems. And here's what you're going to find. For the most part, if you learn about an accelerator pedal position sensor, we'll just stick with that theme, on a GM, you'll find it's pretty much the same piece of hardware on a Kia. If you talk, on the outputs, if we're not talking about sensors, you talk about maybe a variable valve timing solenoid on a Chevy and on a Subaru. They might look different, but they don't necessarily work very differently. So we're going to not try to concentrate on any particular manufacturer, and we're going to try not to concentrate on any particular system. What we're going to do instead is try to learn what these devices are and how they're controlled, or how they feed information into the system, into the computer. So we'll use all data here a lot for examples. We'll be bringing up a lot of wiring diagrams. So the course outcomes. So what are we trying to accomplish here? First, one should be able to describe the behavior of electricity, including voltage, resistance, current, and Ohm's law. So let's talk about that for a minute. As I'm sure you know, computer systems operate on electricity. So does a light bulb, right? So now what's the difference between a light bulb and a computer system? There's a lot. They both work on electricity, but the electricity is used in a different way. So what you'll see is you can use electrical current to operate some sort of device, a motor, a light bulb, a solenoid, a heater grid. You know, this is where you're taking electrical energy and converting it into another form of energy, such as light energy or heat energy or mechanical energy or magnetism, right? So that I call electrical or an electrical circuit. When we talk about electronics, in many cases, especially on the input side, the sensor side, we're not using electricity in that manner. We don't really care about electrical current so much. What we care about is using electricity as a form of information. For example, and I'm just sticking with that whole potentiometer thing, as your foot moves on the accelerator pedal, what changes, what the computer sees changing, is a voltage level. It really doesn't care how much current's flowing. You're not trying to operate anything. You're using the voltage level from that sensor. The computer has a list or a table, basically, knowing that if it's, you know, if it's 0.5 volts, the throttle's closed, or your foot's off the accelerator pedal. If it's 4.5 volts, you got the pedal to the metal. And if it's, 2.5 volts, the pedal is, probably about 50% or halfway down. So it's electricity as information. Another way electricity can be used as information is just completely digital, yes or no. An example would be a brake pedal position switch. You stomp on the brake pedal, voltage level being fed into a pin on the computer goes from 0 to 12 volts. So you're not only operating the brake lights, but you're feeding information into the engine controller, the powertrain control module. In my example, that could affect the operation of the transmission. So you step on the brakes, the powertrain control module knows not to lock up the lockup torque converter, or if it's locked, to unlock it. So the electricity from that brake pedal switch is not running a motor or lighting a light or generating heat or anything else. It's being used as a form of information. The voltage level went from 0 to 12 volts. That means somebody stepped on the brake pedal. In other cases, it goes from a high voltage level down to 0 when somebody operates a switch. In the old days, if you pushed on a power window switch, the current that operates that window motor would flow through that switch. So it was kind of like a light switch in your house. The power is at the switch. When you push the switch, that current is routed to the motor through the switch. That's a straight out electrical system. If you take a modern car and you push on a power window switch, that's not what happens. What happens is a body control or a driver door module, depending on the car, they have all different modules. Let's say a driver door module sees the voltage level on that switch change. And based on that change, that module then applies power to the window motor. So no actual current runs through that window switch. The window switch, it essentially becomes a sensor, and the voltage level from that sensor tells the computer, open the window, close the window, don't do anything. So we're using electricity as a form of information. Hey, the driver just pushed the window switch. hey, the driver just stepped on the brake pedal. Hey, the driver is 30% down on the accelerator pedal, just based on the voltage level coming out of that sensor. So because of what I just said, one of the really important things that we're going to do in this class, and the thing we're going to do next week, is review basic electricity. And I have no intention of reteaching the electrical course, but what I do want is to just make sure you are really comfortable with mostly voltage and resistance. I'm not even that concerned about current. In Ohm's law, I am not going to spend hours belaboring the mathematics involved in calculating current and voltage and resistance. I just want to make sure that you get the concept of Ohm's law, that voltage and resistance and current are tied together. When one changes, so does the other. And a really big thing that maybe wasn't talked about as much in your electrical class is voltage drop, because that plays a big factor in the information aspect of electricity. So number 2, describe the basic operation of a computer-controlled system. And we will, but just really briefly, any computer-controlled system has 3 major components. It has inputs, and so if you're sitting in front of a computer or a laptop, the inputs, the major ones, are the keyboard and mouse. It has outputs, so the monitor, obviously the display is a very obvious one, so are the speakers, the sound card. And then it has the processing portion of it, and that's the innards, the CPU and stuff, memory. So we will talk about common computer system inputs. I've already mentioned a potentiometer. Others are thermistors, switches. Identify and describe common computer system outputs. So these can be relays, they can be solenoids, they can be motors. We need to understand how they all work. But we don't need to talk about every single example of those things. Once you understand how a relay works and how it's controlled by a computer, and how a relay can control a motor like a fuel pump or a cooling fan, then no matter where you see it, no matter what system you see it in, it's going to look the same and it's going to be familiar to you. Number 5, describe diagnostic procedures, including scan tool testing and manual testing, and utilize shop references to identify circuits in their operation. So first, we'll understand how these systems work. Then we'll talk about how to diagnose them. And the repair, usually the repair is the easy part. You're fixing a wire, you're unbolting a part and bolting in a new one. What separates a technician from a wrench turner and a parts changer is the ability to do that diagnosis, to determine what part needs changing. Again, like I did for the lab, I'll let you read the learning outcomes. This is just things that the college insists, happen in our classes, and those objectives of our class that meet those college-wide requirements. Grading is going to be really simple. It's all based on quizzes and tests that I'll give you, and of course, they'll all be online this semester, so I'll announce them as they come along, and the quizzes will only be worth 15%. The final, this is a biggie, the final is worth fully half of your grade. Now, that may seem a little crazy, but let me just dig into that a little bit. When I give you a quiz and you take it, and then usually I go over these in class and talk about, what you got right, what you got wrong, and why. So seeing that we won't have class, I'll have to come up with a way of reviewing these tests after we're done with them. So we'll do that, but every time I give you a test, it will include the questions from earlier tests. So what that means is by the time you get to the final, you'll have seen some of these questions multiple times already. And we will have talked about what the right answer is and why it's the right answer. So it won't be an entire final exam with 60 questions that you've never seen before. There will be some questions you've never seen before, but a lot of them you will have. So as far as attendance, there's no attendance requirements because obviously we're not there, but all I can tell you is if you miss any of these online lectures, which are basically going to be videos, you'll have a very hard time passing the classes. So last thing, just to talk about the actual outline of the class. So you'll notice here there are 14 items. That doesn't mean one item per week. So here's what we're doing right now. Introduction. We're talking about what's in the class. The review of automotive electrical, I think we can do in one video, one class. But this overview, maybe one class. But sometimes I spend several weeks on inputs. Maybe several weeks on outputs. So this is not a one-to-one. It doesn't mean that, week 2 we'll do this, and week 3 we'll do that, and week 4 we'll do that. Some of these things take less than 1 week. Some of these things take more. So we may cover several things in 1 week, and then on another topic spend multiple weeks on that one topic. So let's just go through it really quick. As I already told you, we're going to start with the review of electrical. And the nice thing about this, we do not have separate rules for Ford or Chrysler or Chevy. A Chevy Volt, well, that's a bad example because that's an actual thing, right? So a Honda Volt is the same as a, what did I not use yet? A Dodge Ram or a Ram truck Volt. A Volt on a Subaru is the same as a Volt on a Ford. So we don't have to, cover this over and over again. We're just going to do a basic review of electricity. And then basic computer theory, inputs, outputs, processing, onboard diagnostics. This is the 1,000-foot view of computer systems. Then we get into the actual kind of meat and potatoes here, where we go through various inputs and outputs one at a time. I'll give you examples from different systems. So we've already talked about potentiometers, and I already told you that there are several examples that we've already mentioned, like an accelerator pedal position sensor, or a blend door or mode door sensor in an HVAC system, or a throttle position sensor, right? Thermistors, I mentioned, but I didn't talk about. These are basically temperature sensors, and you find them all over the car. You find them on the engine, you find them in the transmission, you find them in the climate control system, you find it outside the car so that on the dash it can display how cold it is outside or hot. So anytime there's a temperature sensor, it's a thermistor. Switches, as you know, are all over the place. A lot of them are switches that you operate as the driver. Say door lock switches, window switches, all kinds of switches on the dash. But a lot of them are operated by things like pressure or travel. So they're not controlled by you, they're controlled by what's going on in the car. And then signal generators, vehicle speed sensor, crankshaft position sensor, camshaft position sensor. These are things that, generate signals that can give all kinds of information to the computer. Outputs, this is kind of a complete list almost. Solenoids, motors, lights, signals, others. So many things on a car are controlled by solenoids. They can control liquid, they can control motion, they can control various, gas, vapor, vacuum, motors all over the car, lights, obviously, signals. And when I say signals, so one thing that's both an input and an output on these computers is the network. So the output from one computer might be the input to another computer. So we're going to talk about that in enough detail to understand how, if you have a network problem, what do you do? How do you figure it out? How are these networks actually working? Do you need to understand the ISO 9141 protocol? How many, what the exact pattern of bits on the wire means? No, you don't. It's not something you can see anyhow. But just understanding that there's a difference between these, and as a general rule, vehicles have more than one network. They might have single wire CAN, high speed CAN, medium speed CAN, and just understanding what all this means. We will talk a little bit about what goes on inside the processor. And the reason for that, I just want you to understand what computers can and can't do. They're big calculators. Onboard diagnostics really important, so to understand what's going on. And the idea behind onboard diagnostics is this is stuff that's built into the car. It's on board. It's driving down the road with you when you're driving the car. It's not a scan tool or anything. And then we'll talk some about individual systems, right? This is really old stuff, OBD1 now. It's 25 years old. So we're going to spend a very short time talking about that. But the reason we talk about it at all is that OBD2 took OBD1 and added on to it. So that's really where we're going to concentrate, talking about, maybe not for all of these systems individually, but just what onboard diagnostics started at, and then what was added on over time. And then the use of scan tools for retrieving diagnostic trouble codes and serial data streams. We'll talk about diagnostic trouble codes. We have different kinds. We have pending, we have active, we have stored codes. We have body codes, we have chassis codes, we have network codes. What are the differences between all of those? And then finally, use of pinpoint testing to identify what caused those codes. So pinpoint testing is, you get a code that tells you that some sensor reading is out of range or is off. You got to figure out why. Let's say I get a code for an oxygen sensor, and all the code is telling me is that the oxygen sensor's not putting out what it's supposed to. Well, you don't know if it's unplugged or if it's defective, if the wire's cut, if it's contaminated. So pinpoint test will take you to the actual thing that's causing that code. Down here, there's information about students with disabilities and who to contact if that's you. This is confidential information, so this is not something you necessarily even have to tell me about. That's voluntary. But if there are special accommodations that you need, like for example, testing, maybe you don't do so well with testing and you need to go to the counseling center and have questions read to you. That is something that's available, for example. And we do use Starfish, so sometimes I may put a comment in Starfish, and that might result in somebody reaching out to you to see if they can help you. I would hopefully not have to worry too much about the academic integrity part here. But when I put a test on Blackboard, it is my intention that you do it yourself. Obviously, I can't see who's sitting at the computer. I can't see if several of you are working on it together. All I can say is, you know, at some point, if you go out into the world of work, nobody's going to be able to help you with that. So you need to learn this material, and you know, the best way to do that is by handling all this stuff yourself. So for this week, that's all there is. I will, before next Thursday, I'll have posted a video, you know, starting into that review of basic electricity. And obviously, anytime I post something new, you'll get an email. When I put something on Blackboard that's new, I'll send you an email myself telling you it's there. Sometimes Blackboard notifies you of these things as well. So there should be no reason. The biggest thing is keep an eye on your ECC email account, not a Gmail account or anything like that, because all of these tools like Blackboard and Starfish, if I email you through them, it only knows your ECC account. It doesn't know any of those other ones. So you got to check your ECC account. And hopefully, and I know most of you are not only in the lecture, but you're in labs too. So the first couple weeks, you know, in January, we're completely remote, but in February we start with the labs in person. And then hopefully, if you have questions, I know in the past people have, you know, watched these lecture videos and maybe don't understand something. If you see me in lab, we can talk about it. Other than that, feel free to email me, leave me a voicemail. If you don't understand something, I want to make sure that you understand it. If watching these videos isn't doing it and you need more of a back and forth, we can arrange to have a video conference where we can be face to face. And you can ask questions and I can answer them. So, but you got to talk to me. You got to tell me about it and let me know that it's a problem. So I'll have something posted next week, and until then, well, good luck, and looking forward to seeing you all in February.